Hello. Now we're going to do problem 2, which is our confidence interval problem. Let me get the pen working here. Okay, so we have n equal to 49. And in our class, as soon as n is greater than 30, we're going to switch over and use the z table for our references. Our x bar is equal to 13.25. Sigma is equal to 1.25. Now you notice here that we use sigma rather than s because this is the population standard deviation. And let's look at our formula for a minute. So we have x bar plus or minus z with the subscript alpha over 2 times sigma over the square root of n. So the nice thing about these is that you're given 3 of the 4 pieces just in the story themselves, and the only thing that you have to do is find the value of the z with subscript alpha over 2. And since this is a 95% confidence interval, this is one of our particular favorites, we can just say 1 minus alpha is equal to 0.95, 0.95 referring to 95%. Take 1 minus alpha over 2 equal to 0.95 over 2, and that gives me 0.4750. Okay, that's a probability. I look in the middle of the z table for the value that matches up to that, and there's an exact hit, and I get the z from 1.9 plus 0.06, and that gives me 1.96. Good. Now we want to put the whole thing together. So we have 13.25 plus or minus 1.96, that's a 6, times 1.25 over the square root of 49. And that's going to give me 13.25 plus or minus 1.96 times something to the effect of 0.1786. And I multiply that together, and that gives me about 0.35. So I have 13.25 plus or minus 0.35, so that gives me 12.90, less than mean mu, less than 13.60. So now for my interpretation, I say that we are 95% sure that mu falls in this particular interval, just in this interval. So instead of going from minus infinity to positive infinity, we traded in 5% of risk, and we're now down to between 12.90 and 13.60. All right? Great.